Hello. Panel work, cutting holes in boxes, panels, enclosures, or general pieces of metal and plastic to mount things in, such as switches, volume controls, connectors, things like valve or tube bases, if into that type of thing. There's lots of techniques and there are lots of ways of doing it, and some work better than others. So for people that's not got a lot of experience, I thought I'd run over a few of the things I use. Now, the most obvious is just a small drill. A little cheap drill, lots of boxes of bits to get from the supermarket for general work when they put them on sale especially, which last okay in plastic, but not very good quality these, but they work. Obviously you just mark where you want the hole and drill a hole, which is great for a small hole. I'm going to say probably that. I'll just move this out of the way and get something so I don't make a mess in here. So that's just a bit of scrap trunk used for demonstrations. So I want to drill a hole in that. Then for a small hole, you can put it where you want, it's going to come out fairly well. The problems arise when you want bigger holes. Then things start to get difficult, especially in soft materials, unless you've got some fancy equipment like a bench pillar drill or that type of thing. Because when you try and enlarge a hole using a normal drill bit, it tends to run off centre. It kind of goes around in a pentagonal pattern, 5-way or whatever. Put flats on it, and also it tends to bite and kick and snag rather badly as it goes through, and often that can be quite violent, especially if you're trying to cut something like aluminium, aluminium chassis or a metal box. Which I can probably demonstrate in this. I can do it without cutting my hand. Right, well you can see that it's instantly digging in, and it's gone at all crazy angle. It's just trying to twist it out of my hand. And if I manage to hold it long enough to get it to go through, of course it's just snagged. It does not want to come out, and generally it's very awkward. If you a bit of force, you can get the thing to come out. It's not easy. And it's messy. You can see that hole is rather ragged. It's just got stress marks on the plastic near it. A much better tool is a step drill. Put the same hole in the plastic to start with, which I think was that one. I'll put another hole in there, put it horizontally, it's easy to hold at this angle. Notice I've got the drill on low speed because it's a lot more controllable. If something does start to go wrong, you've got more time to correct it. And also, it doesn't heat the plastic up so much, especially when you're drilling plastic, or especially when you're tapping it. If you ever try to tap holes in plastic, the friction can actually get to the point where it starts to melt the plastic and make it flow, which can get very messy, and it can end up with things going out of line or the drill sticking as it cools down again, all sorts of things. So using lower speeds in plastic can be very useful. Now, to enlarge that, I'm going to take it out a little bit with just a slightly bigger drill. So I go up to 5mm, which a small increase generally it's okay, it's not going to snag. On a smallish drill like this. See, that's gone through nicely, it's not snagged. It's not made a mess. And even if it had slightly, as long as it stayed on centre, it wouldn't matter. And that is a step drill. You can actually use this directly, but it doesn't centre very well. you need a little bit of a hole. That could have gone straight into that other hole and cut the first stage itself. You see this one's actually marked with sizes. So it goes, you can see the markings there. It's 4, 6, 8, 10 and 12 millimetres on the various steps. And unlike a big drill directly, these don't snag or have very minimal effects. Now I'm holding this in my hand so it can easily twist. Actually, oh sorry, do that one. That's straight out to 12 mil. I could have stopped at any stage, but I want to show how big it'll cut easily. 12 millimeters, no snagging, and an absolutely perfect clean hole. There might be a little bit of burr on the other side. Actually, not much on this one, but the effect compared to a normal drill bit is phenomenal. The finish you get is much better, and you can get these things in all sorts of sizes, up to like 50 mil, 2 inch or something like that, or even more. I don't know. And this is the biggest one I've got. You see, you can start it with a smaller one just for convenience, and then that will go up to 32 millimeters, I believe. Yeah, that goes up to 32 millimeters in 2 millimeter steps. Is it 30? Oh, sorry, 35 millimeters. All right. It's more than that. 35 millimeters in 2 millimeter steps. And you can get all sorts of different sizes and versions of them. One common one, and it's also probably a very cheap one if you're looking around, is for electrical conduit sizes. So that's only got a limited number of steps. It's 16, 20, 25 and 32 millimeters. But the intermediate ones give you quite useful sizes. In fact, that next to last one is about 22.5 mil. So I very often use that for 22 millimeter panel switches. And you can use these in steel or anything, and plastic, aluminium, brass. Doesn't matter what. It's as easy as this. Obviously, a lot more cutting torque with a bigger bit, but the finish and the effects are just the same as with a smaller one. In there, you get a nice clean hole, and it's a lot easier than a drill, a conventional drill bit. And that's okay for round holes. Perhaps if you want other shapes, or you haven't got these, you've only got small bits and you want a neat big hole. There's several other techniques for opening out holes. One of the oldest and simplest is called broaching, which is used by jewellers and watchmakers. I don't know what I've done with the thing, I need to demonstrate it. Just for demonstration, this is the first convenient thing I could find. It's a little punch. You can see it's got a completely smooth, tapered section on there. No cutting edges, no nothing. If I got a hole and I could only make a small one, say 3 mil, just put something in here. A demo. I got that hole and I needed that to be, say, 6 mil or something, or 5 mil. Put that in, just wobble it around slightly. Keep pressing, just keep wobbling. This is a technique that's been used by watchmakers and clockmakers for, well, just about since the introduction of clocks or even miniature gearing, for enlarging holes precisely. As you can see, it's going through it very slowly. If you move it a wider angle, it'll go quicker. You can keep going around and push it through a bit. A very narrow movement, it will go through very slowly and just very fractionally keep expanding the hole as you wobble it. And say you're trying to fit a lead in, 3mm lead, for example, you could keep doing that until you got to the point it was just a snug fit. It will actually burr the panel slightly, that's unavoidable. But if you use it for mechanical mountings, that can actually make it stronger, especially when you put a thread in afterwards, because you're making the panel thicker, so the thread's deeper and more strength. Sounds a bit odd, but that's how it works. Same as if it was going to be for a bearing of some sort. Because the metal's being squeezed outwards, it's got a kind of little volcano ridge on either side. It makes it stronger. And then obviously the more force and the more angle, the more the thing will go in and the more expansion you get. I mean, it's a kind of last resort or just for tweaking holes a bit if you can't quite get the right size you want, because you can make it any size with that. Now, there are other tools you can use also for enlarging holes, which unfortunately one of my favourites. I've recently wrecked using it in a piece of metal that was way too hard for it as a last resort because it was something I had to do on the spot. But tapered reamers. You can get these very easily on eBay, Amazon, or any tool place, or AliExpress or anywhere. The most useful one I had started at 3mm and went out to about 1/2 inch. Same T-handle, about that diameter shaft on it. As long as you can get it to start in the hole, you can then just keep turning it and it will keep progressively cutting to any size you want along its range. It's not exactly fast, but again, you can create any size hole you need, which is very, very useful. And you can stop whenever you want and keep checking until you get to the spot on correct size hole. And there's actually another power tool version of that, which is a cone cut. Might be a brand name, but this style. These, again, the power tool one, but you just keep going in as far as you need to get the size you want. They tend to be in larger sizes. The bigger one I've got in the parts with that massive cone cut is a similar size to that. It goes up to about probably 35-40mm. Obviously these need a hole big enough to start it, and they can't do anything smaller than that. They've got to get onto the proper taper before you can control the cutting prop easily. But again, that will just go in as far as needed to give you a nice round hole of any size you want. I use the bigger one to do the holes in this panel to take these little adapters I made. There's one with the joysticks on it, and these little joystick, I think they're sold as PS2 joystick modules. They're 45p on AliExpress, or maybe less than 45-50p range, but different sellers, probably about 60-70 cents. But they are horrible things to mount because they mount on the back, not the front. So I made these, which are on Thingiverse if you want to use them yourself. For larger holes, like big cutouts, there are again a range of different options. One of those is a nibbling tool. You can't find out where I put that now either. Oh, it's there. You can get these in various styles. This is one I've had for literally 40 years. There's another style with the handle hinged near the top and a curved handle on it, typically a chrome finish one, but these black ones, these are quite reasonable. And with these, you need a pilot hole in the corner of whatever you're cutting, or somewhere in the area that you're cutting, big enough to take the cutting tip. I mean, this hole's now too big, but it should still work as a demonstration. And all you do is just put that thing in, and you can follow a line, and it just takes a little chunk out each time. one side, the left on this, gives a straight, clean edge. The one tends to be a bit rough. But you can then cut at any angle and work round to cut a straight-sided shape, or an irregular shape even, and file it. You could keep working around in a curve and then file it into a smooth shape that you want. So again, a very versatile tool for thin materials. It only goes up to about 2 millimeters. If you haven't got that, you want to cut big holes, there's another technique, which is another one I use very often. Works on thicker materials, like these boxes, this panel. That's quite a thick one. That's about, getting on for 4mm, I should think. Same as this. It's too thick for the nibbling tool. And the technique for that is drill a lot of holes. Now, I actually did a separate video showing me fitting this little meter insert into this box. But just in brief, I'll probably fast forward this bit. Oh, before I go there, sorry, one of the other things is marking out. Obviously, the absolutely basic essential thing is a ruler and something to score, or rather pencil, or depending on what you're working with. If you're on the inside of a box, you can scratch lines with something with a point. It's not very obvious, but there's a scored line there. Use a pencil, draw on it. If you work on the outside of the box, you can put masking tape over it, painter's tape. Draw on that and cut through it, and then peel it off afterwards so you don't mark the outside of the box. But basically, you need to mark a shape. When you're working, trying to get accurate dimensions for something, just using a ruler can be a bit tricky. So one of the most useful things you can have is a pair of verniers, especially digital vernier calipers. But normal mechanical verniers are fine. I used them for many years before I bought my first digital ones. I thought I brought another pair as well. These are good ones. But I've got some cheap, nasty supermarket ones, about £5. You probably get them with that or even less online. But basically, if you want a parallel line on something, like for marking, say I want to align. I wanted to put another hole in there at 35mm from the end. So not 35mm. Or near enough. And you can use these as get in line with the end of the thing and on the line, and then just use that as a tip, as a scriber. My engineering teacher would no doubt throw a fit, see me do things like that. But the milled Lauren Wright mechanical ones, non-digitals, I use those for like 20 years doing that all the time, and because I only ever do it on soft materials, the tips are never marked at all, they're never polished off. So plastic and aluminium brass, things like that, it won't really do any harm if you're gentle. But what you do is you get nice precise markings. If you want to go a full parallel line, you can just draw along with the jaw resting on the edge all the way. That's how I typically mark stuff like this. So once you have your markings, I need to score this a bit more heavily to be able to see what I'm doing with it, to demonstrate it. Should really have got a fibre tip or something to do that. That's more like it, you can see that. So I wanted to do a hole in that, a certain size, and it was too thick for the nibbling tool. Okay, doorbell interrupts video. Right, so as I was saying, if that's when you want to cut out and it's too thick for a nibbling tool, or you didn't have a nibbling tool, again, this is a method used for many years before I discovered the fancier tools. A line of holes just inside the outline you want to cut. Now, if it's a very small shape, you can do them very close and do them almost touching. If it's a big shape, do them a bit further in and a bit further apart. So that's if I was doing a very big hole or something like that, display hole, then I'd do it like that. For a small shape, I'd probably work close into the corners and close to the line. And for the big one, you can then go along with a bigger bit, whatever size you need. So probably I'd do that so it would be about a 6mm that will be close to the line and more or less overlap. But doing the small holes, once you've got a line like that, this is cheating. You've got to be careful you don't break the drill bit, but you're actually using the drill by twisting it sideways. You're using the edges as a milling cutter and reducing the amount of material between the holes until there was very little, and you can just pinch it with side cutters to cut it, or like that where it just goes away completely and you're left with a moderately straight edge that you can then file up. And so with the bigger ones, this is just quicker if you've got a long run to do, rather than doing 50 like that. You can do like about a third as many and use a bigger drill afterwards. Same technique, just sideways and break out the bits and then start filing. And so with that you can do pretty much any size or shape, and it works fine in aluminium panels or brass sheet or like I say plastic, very easy in plastic. It's don't much filing. Actually with some types of plastic you don't even have to file it initially. You can use a good sharp craft knife or a snap blade knife, a box cutter, and just very carefully go along and clean up the edges to virtually on the line, or even if you're careful, exactly on the line, especially if it's something that's got a visible, like a bezel on the front. I mean, that one hasn't, but so like something like this, it's got a bezel on the front that overlaps the edge of the hole, so it doesn't matter if the edge isn't perfect because you're never going to see it. And that allows you to cut any size you want, just using a smallish drill bit and a hand tool. I mean, you don't even need an electric drill. You know, things like this, you can find one of these still. Just a hand brace like that. That's what I used for, again, before I got power tools or anything. I've done an awful lot of chassis work with that. Speaking of chassis work, this making and finishing boxes or electrical chassis or electronic chassis, like amplifier chassis, that's, by anyone old enough, that's known as chassis bashing, for the simple reason that in the old days, or if you wanted anything special, and still now if you want anything special shape, you like it, trying to make a valve amplifier or something like that, where you need a big aluminium chassis, or you want it to look like a classic amplifier, guitar amplifier, which is typically an open box kind of chassis, you'd have to make it out yourself out of aluminium. That's another technique. I'm not going to use a piece of aluminium because I haven't got any spare. I'll show you the basic concept. You get a suitable size aluminium and thickness aluminium for the area you want to work with. I mean, if you're working a small box like this type of size, then a 1mm would be enough. If you're making something, say 150, 200mm wide, like a medium-sized valve chassis, then 1.5mm. Making a really big one, maybe 2mm. But the concept's the same. That's the top plate that you want, and then equal depths all the way around are the side flanges, the downwards extending parts of the box. Cut each side and then take out each corner with tin snips. I mean, something like this, they'll cut 1 to 2mm aluminium very easily. Again, it can be a bit tedious working through it. You've got to be careful as you work in, when the cuts longer than the blade, that you try and keep the offcut bending away from the panel, so you don't kink the edge of the panel. But you can always just tap it straight on a flat surface with a hammer. I'm going to do this with scissors because it's on a bit of cardboard for demonstrations. But the concept's the same. Ultra precise either, because it doesn't really matter. If I was doing it properly with aluminium, I'd file the edges and draw file them to finish them before bending it. The same technique as with the tin steps, trying to keep the waste as the bit that creases, so you don't bend the panel itself. That's the overall size, which we'll then clean up. Then take the corners out very carefully on these, because this is going to affect how accurate the top plate is. Now this is corrugated cardboard, which won't bend very easily in both directions or accurately, but I'm hoping to get it to work, just for demonstration. Yeah, there we go. You might have to just stop fractionally short of the corners, then break it a piece out and file the corner to get it neat and accurate. Oh, sidetracking. Talking of filing, that's something I meant to mention. That broaching technique and taper reamer technique, you could also cheat on that with panel work and use a square or triangular file. It's like, that's one of the things we're going to show you with these. I've only got 6mm and 8mm bits in that kit. These need 6.3 1/4" and 7mm holes. Don't fit those. The shafts fit, but the actual threaded section doesn't, so you can't fasten them in. That'll go in, just tight it'll go, and just turn it in and keep cutting. It's a cross between broaching and reaming. It's cheating, but take it out again slowly. That switch will now fit. It's a bit burred, but round that back down with the tip of a screwdriver or something, or fingernail, and the switch will bolt in. It's not that bad a fit, and the nut will cover the slight burr. So there's all sorts of ways. I mean, again, you can do the same thing with this in aluminium or brass, any soft metal. Might be a bit harder to do it, but it'll work. Just don't lever it. Stick to turning only, because files tend to be brittle. If you try and lever it, you'll probably shatter it. Now back to the chassis bashing bit. So once you've got your form, you need to use a vise. So put the edge in a vise with the line fractionally above, about by the thickness of the metal, the jaw, and then start. I'll have to see if I can emulate the vise with the. Oh, there's the cheap ones. Emulate the vise with these. So put in there, hold it in the vise and bend. So put a fold on the tabs. To work all the way around, and you get it accurate, which that wasn't very, you end up with an open bottom box, which is electrical chassis. It's a classic style. If the piece you're bending is bigger than the vice jaws, so you can only clamp a part of it, only do it a very small amount of bend each time and keep working backwards and forwards. Because if you bend it, if you try and bend it too much in one go, I mean this just creases up. But the effect on metal or whatever, or if you're in plastic, if you're doing it with some kind of plastic, you can do it, is it will stretch the edge and it will never go straight again. Because the outer edge is being stretched. I can tell them because it was being stretched so much, and you end up with a banana-shaped box. So only bend a small amount. Don't try to undo it in one go. Do it in like about 8 to 10 stages and work backwards and forwards. If you've got bending bars or two big pieces of flat metal strip you can clamp it between, that's great. And you don't need to worry about it, but if you can only clamp a small area, then you need to be very careful. So if it's, I've done that backwards. It's so long since I've done one, I've done it backwards. You should do the shorter edges first, because unless they're all bigger than the vice jaw, because once you've bent those, you can't bend those. So do the short edges first. That's a classic mistake. I've done that with metal, and you end up saying unreasonable things about yourself. Anyway, to do the short edges first, because the long ones aren't in the way for that, and then do the longer ones afterwards, and you have a box chassis. If you want to make a complete box enclosure, you can do it with, say, 2 short edges, and then make just a U channel back that fits around it. I'll do a bit of that. This is a short piece, but you get the idea. You make a U channel back that fits around it. It's just a fraction bigger to make a complete box. You could even put short flanges on that as well, so they fit inside the end tabs. And there's various ways of doing it, but again, you can make complete boxes. I've done that in the past. Okay, I think I've just about covered everything. I can't remember what I've forgotten anyway, so hopefully that's of use and interest. And now I'm going to finish doing these holes. Oops, that's not fast enough yet.